Now, what is position as opposed to anything else? Well, position of an object is where an object is with respect to the origin. And parenthetically, I'm just going to write 0. If it's a number line, you generally just don't call it the origin. At least I don't recall when doing that. It's 0 in a number line. In a graph, it's called the origin. So, for example, I'm going to go ahead and make this my origin right here. And I am going to just make to the right positive, because why not? Just think about this like a number line. Right now, my position, positive, negative, or 0. Am I at the origin? Which is over there.
No.
All right, so it's not 0. Am I on the plus side of the origin?
Yes.
Okay, so therefore, my position is positive, negative, or 0.
Positive.
Positive, there we go. My position now,
Positive.
all right, so if we get a little parallax here so that it potentially we'll get two different views. If it looks like I'm hovering around 0, it's supposed to be at 0. So my position
0.
and my position now.
Negative.
All right, this is the way the game is played. Questions up to here before we throw in another vocab word. Where an object is with respect to WRT, with respect to the origin, or 0, whichever one you're calling it. And I haven't forgotten scalars there, we'll get to it. Displacement. Displacement is another word that automatically you should be thinking. You see displacement, you should be thinking vector. Direction matters. The symbol for displacement looks a whole lot like position, except we have to indicate that it's a change. Because displacement, there's basically two definitions. There it is changed in position. And or where an object is with respect to the starting point.
How is that different from origin in technical terms?
All right. Let's say that I'm going to start here. My origin is still over there. Let's get rid of this stuff. I'm going to make that my starting point. And maybe even spell it correctly. So I'm starting here, my displacement 0. I haven't gone anywhere. But I still have a positive position because I'm on the plus side of 0. Over here, my position, there we go, my displacement. Am I on the positive side of my starting point or the negative side? I'm on the positive side, so I have positive displacement. If I am here, my displacement is
Negative.
my position, positive because I'm on the plus side. And over here, negative. Both are negative. Now another way of looking at it is who doesn't love a graph? Let's say that's my origin right there. Sort of imagine 2 dimensions. Start my origin right there, and I've got an object here. You can picture a map potentially, and you just draw coordinate axes on a map, and you pick where you are right now. This would be your initial position, which I would label. I'd use the X symbol for position, and then put a little I there for initial. And then you go over here. So now you're over here. This is your position. That's your final position. So let's say that's school and home. Your displacement is the difference in that, the change in the position, or just where are you relative to where you started. So that's the displacement. Does that answer it? Okay. The symbol used, well, it comes down to change. Anyone know what the symbol for change is?
Triangle.
Yep, triangle. So, delta, it's a Greek letter delta, or it is a triangle, but delta x, delta y, and so on. It's just, you put the delta, the triangle in front of whatever letter you're using for position. As I did right there. Now there is a scalar analog of it. That is called distance. This doesn't care about direction. If you're traveling by car, it's what the odometer reads. I started at home this morning, I drove to school, I'll drive back. Let's assume that my odometer changes 10 miles. That's what I want. The distance I traveled, so I start at home, I come to school, I travel back, let's say it's 5 miles each way, I travel just reverse of what I did before. The distance that I covered is 10 miles. My displacement is 0 meters. After an entire day, I've gone nowhere. I'm gonna end up back where I started this morning. I haven't gone anywhere. So from a vector point of view, my displacement is 0, the distance traveled is different. So, questions at this point? All right, the next vector term, velocity. I'm not sure why I'm capitalizing it, but velocity. The symbol for velocity, it's one of those things where you go, and how did they think of this stuff? It's a V with a vector symbol over it. It is how fast and in what direction an object is moving. Or the change in position divided by the change in time. Or displacement over change in time. In other words, where do you end up relative to where you started, divided by how much time it took to get you there. Now, I'm going to break this into 2 types. When you're dealing with velocity, there's instantaneous and there's average. Instantaneous is the velocity at that very moment that you're trying to find the velocity. Average is over the course of some time, where are you relative to where you started. This is actually the formula here for average velocity. And if you had calculus, you just let delta t go to 0, not equal 0, just gets incredibly close to 0, and you get instantaneous. Otherwise known as a first derivative. Now, it's a quiz or a test, and I say find the velocity. Which one am I asking you to find? If all I say is just find the velocity, I'm asking for the instantaneous. If I want you to find the average velocity, I will specifically say, what is the average velocity? Displacement, you could also have instantaneous displacement and overall displacement, so there are the two types of instantaneous and overall. If I say what is the displacement, default is overall. If I want instantaneous displacement, then I will specifically say. And that comes down to what do you consider the starting point? If I move from here and then back, at the moment when I was here, what was my displacement? Well, I could compare to where I started the whole trip, or I could compare to where I was just a moment before. So overall, I was on that side of my starting point, but instantaneously, I was on this side of where I was just a moment ago. But overall, when I just ask for displacement, overall, if I want the other one, I'll specifically say, and for velocity, I want instantaneous unless I specify average specifically. So, Columbia, South Carolina, Winston-Salem, about 200 miles, we'll just assume due north. And we'll just make that the positive direction, because why not? Yeah, actually, I just put n hat to represent the fact, my unit vector. We did unit vectors already, right? Okay. So 200 miles. So I start in Columbia, and I take the scenic route. Got to stop by south of the border over here. All right. The car's odometer has said I've gone 500 miles. It took me 10 hours for the entire trip. So first off, what is the distance traveled? Yeah. Oh, I didn't put down the symbol. The symbol for distance looks a whole lot like the symbol for displacement, except no vector symbol. So distance would be delta x, delta y, delta whatever you're doing. Just no vector symbol. The scalar equivalent of velocity, in other words, how fast you're going, what is that generally called? I think somebody just said it. Speed. The symbol for speed is v, without the vector symbol. All right, so I go at 500 miles, so the distance traveled, let's see if I can do this more efficiently than I have been. Circle, and then, there we go. So the distance traveled is 500 miles. What is my displacement?
300.
Not 300.
200.
Keep going. And I got the 200 miles. There's still one more piece missing. I think somebody just said it.
More.
Yes. My displacement, 200 miles north. So, very clear difference between the two. One is wear and tear on the vehicle, the other one is just where am I relative to where I started. All right, my average velocity for my trip is what? You answered this next question. It's not. Is it 500? No. Sorry, you didn't answer the next question. That's not right. How do you find average velocity? So what am I dividing?
510. 200 divided by.
Or is it 200?
Divided by
10.
Yeah,
So 20?
is that what you were saying? Oh, I'm sorry. You have to, again, I have tinnitus, speak loudly. And it's all good. All right, so I have 200 miles north divided by 10 hours. So my average velocity is 20 miles per hour north. My average speed, well, very similar, except instead of displacement over time, it's distance over time. My average speed is what?
500 over 10.
Which is
50
units?
miles per hour.
Yeah. So my average on the car is 50 miles per hour, but my average velocity is 20 miles per hour north. All right, how is this useful? Well, let me give myself a little ego boost here, and you can do the same for yourself. You are in a race with Usain Bolt. This is the start and finish. Start and finish. 400 meters all the way around. Usain Bolt and I are both right here, gun fires, and we both go off running. He gets around the entire track, ends up right there in, we'll just say, 40 seconds. I do the whole track in 100 seconds. At the end of the race, when he gets to the finish line, what is his average velocity?
Would it be
Right.
10?
Pardon?
Would it be 10?
No. All right, let's go back to average velocity. Again, velocity is the vector one, is the displacement divided by time. When he gets to back to where he started, what is his displacement? The answer is easier than you think.
Is it 400?
0. What? No, it doesn't.
I heard 400, I heard 50. The people just seeing the numbers they see up there.
Wouldn't it be 0? His position, like, he started where he finished, right?
Therefore,
It's nothing, or it's 0.
he has gone 0 meters in 40 seconds. So his average velocity is 0 meters per second. When I get to the finish line, it's taking me longer to get there. Well, it's my average velocity for the entire race.
0.
I'm as fast as Usain Bolt. I can even do it one better. When he finishes his race, I'm somewhere over here. After 40 seconds, I'm here, 40 seconds, he's there. Where is he relative to where he started? So his average velocity is 0. My average velocity is not. The magnitude of my average velocity is more than his. I'm faster than Usain Bolt. Because I've gone somewhere in 40 seconds, he's gone nowhere in 40 seconds. Now, obviously, if we were to compare speeds, it would be a different story. And then I would realize that my number is completely unrealistic, because it would take me far longer than that to make it around the track, but just for the sake of this. So his speed is faster because the distance traveled per unit time is greater, but I prefer to think of it in vector terms. Questions to there? Is Usain Bolt still the fastest man alive? Or has he gotten past at this point? I was doing Carl Lewis references for the longest time, and then eventually got a group of people who said, who? And so, now I was doing Usain Bolt, I was just wondering at what point are people that have no idea who he is? You don't know who he is?
It's still him.
No, I know who it is.
Okay,
Yeah.
It's still him.
I think it's still.
It's still him?
Yeah.
okay. All right, let's get back to plus minus zero. Velocity cares about the direction I'm moving in. So right now, my velocity is, again, that way's positive, there's my origin, my starting point's over there. Yep, my velocity is negative. What about my velocity now? What about my position? Displacement? My displacement now? Position? Velocity? So recognize how one doesn't really, knowing the sign of velocity does not really tell me where I am. There's not a relationship between what the velocity is and what the position or displacement is. There is a relationship between velocity and change in position. Sort of instantaneous. All right, see if we can do this quickly. Position, displacement, velocity. Yep. I heard some faint people saying zero, but yes, it is zero. All right, velocity, position, displacement, displacement be negative because it's based on that. Velocity now. All right. As I move this way, my velocity is positive, and now my velocity is negative. What happened at that turnaround point? What was my velocity at the turnaround? Yeah, it was said faintly, at least in my ears. Zero. You can't go from a positive to a negative value. In a one-dimensional problem, you can't go from positive to negative without passing through zero. The only way that you could do it would be a rip in the space-time continuum, and that is well outside the scope of the course.